Hi, I'm Debbie with Nixine Publishing, and we're continuing our series about graphene with Adrian Nixon, who is editor-in-chief of the Nixine Journal, coming to us from Yorkshire, England. Today we're going to talk about something that's a little bit different. I have another question for you, which is, can graphene help keep our food safe?
Short answer is yes. There's a lot of work going on at the moment looking at graphene in plastics, polymers that are used in food packaging. The big problem you've got in food packaging is, there are a number of problems. Ideally, you'd like the material you put the food in to be very clean and also transparent so you can see what's going on inside. But also it's got to keep it fresh. So the way a lot of food producers work, they'll put a gas in which doesn't interact with the food and pressurizes it slightly. And usually that is nitrogen. So you're using that to exclude oxygen. So you probably noticed you get a bag of crisps, I think you call them chips in the States, that they're usually in a metallized foil bag and they're pressurized slightly. You've probably noticed that.
I just thought it was air. I didn't know it was nitrogen.
It's nitrogen from the air, so they exclude the oxygen, and that keeps the crisps or the chips fresh and crunchy when you open the bag. And it's metallized foil bag because they coat the surface of the plastic with very tiny film of metal to actually increase the porosity, to stop the gas from leaking out. Otherwise it ends up like a party balloon. You know, with these helium balloons, they just deflate over time. Yeah, that's what would go on. And then the oxygen would get in as the nitrogen came out, and then your food would go off. You don't, with soggy crisps that taste a bit sour. Nobody wants that. Yeah. The problem is that the metallized foil works okay, but it can't be recycled very easily because the bag is sort of like it's got a plastic bit, a metal bit, and other things going on, various inks and things. So at the moment, certainly in the UK, I don't know what it's like where you live, we can't recycle these crisp bags. We need a material to make the food packaging out of that is made of materials that are fairly common and well known and understood, that are safe, but also we can blend with graphene and make an improvement there. If we think about food packaging, then the problem we've got to overcome is if this green box here is just like a cross-section of plastic packaging that's used for food, we've got to stop the gases passing through the material. At the moment, they tend to pass straight through the plastics. So either you get oxygen coming in and spoiling the food, or nitrogen going out as well. Oxygen and nitrogen are the two main ones. Carbon dioxide is also important too, for things like beer and things like that. If we look at what graphene composites do, then the graphene nanoplatelets all sort of jumble up and they form what's called a tortuous path. And so now what the gas has to do, it has to sort of navigate all these different little channels, and it's a very long, tortuous path to get through. And what that means is it dramatically slows down the passage of gas molecules and it reduces the porosity. Are you with me so far?
Yes, it's very fascinating to see how graphene does that.
And the important thing here is it's gases coming in as well as gases going out. So we need to look at oxygen and nitrogen. I had a look in the literature and I found this research which looks at a polymer called polylactic acid. Polylactic acid sounds a bit chemically. It's actually made from, it's a thermoplastic biopolymer that's made from cornstarch or rice or sugarcane. So it's a renewable plastic, and it's already used for beverage packaging and food packaging, and it's approved by the FDA. These two graphs here, the blue one on this side shows the results with oxygen, and on the pink side here shows the results with nitrogen. If we have a look here, the vertical axis is the permeability of the gas. Oxygen over here, nitrogen over here. So the higher the number, the more gas is getting through. So the more porous the polymer is. And then along the x-axis at the bottom, we've got the yellow bars is just graphene nanoplates, and then graphene oxide is the green bar in both cases. So here we can see the results for oxygen with no graphene added to the polymer, and you can see a lot of gas gets through. But very quickly, as we add quite small amounts of graphene to the mix, 0.2, 0.4, 0.6%, then it does dramatically seem to stop the gas coming through. And then the same thing over here with nitrogen too. With Again, small amounts of graphene or graphene oxide seem to stop the nitrogen coming through. Interestingly, the work here showed that graphene was probably slightly more efficient than graphene oxide was for nitrogen, whereas there's not a massive amount of difference for oxygen here. But Debbie, there's one thing you pointed out in a previous example about composites, which was the less you add is more.
Yes, yes. And I was noticing on this one that if 0 is what is happening right now with how much, how fresh food is, how long it lasts on the shelf, then you could easily look at that chart and say that now you're more than doubling shelf life of food simply by adding some graphene to the packaging.
On the face of it, yes, you could do. I haven't seen the data which is actually being done with real food, because this research was just looking at passing oxygen gas and nitrogen gas in the lab, so they didn't use food. But you could make that case, Debbie. There's another piece of research which needs to be tagged onto this, which then says, right, let's take this into real food packaging and we'll look at how long we've extended the food life for. You're absolutely right. It will extend the shelf life of the food, no doubt about it. How long? And what's the relationship between porosity and shelf life preservation? We don't know until the lab work's been done. But yes, you're absolutely right. You're on the money there.
Wow. That's something else. You add a little bit of graphene and you get such amazing, we have all the superlatives to begin with, and now we have all the amazing results.
Yeah.
So,
yeah. And when we were in DC, we were talking to a company that was putting graphene into polyethylene terephthalate, the PET bottles. And I think they were going to use it for beer, weren't they?
Beer in plastic bottles, imagine that.
Yeah, and at the moment it's sold in glasses and cans because they're not very porous, and it's not put in plastic bottles because oxygen gets through and spoils the beer. But put graphene in, and hopefully we can get graphene in recyclable plastic bottles. So coming to a shop near you soon.
All right, well, Adrian, thanks so much for this great information, and we'll be back again with another episode.
Great. See you again, Debbie.